notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018. Normally it would run for 10 years unless revised. As of now, December 2025, this syllabus has not been revised, and there are plans to change just the structure of the exam from 2028 onwards. Currently, there are a few pilot projects now being conducted in a few Caribbean countries. Two main plan changes are: one, to split this CSEC math exam into two parts, maybe a level 1 and a level 2. And two, there will no longer be any alternative sections. Mandatory questions will be set on all sections. Schedule of videos. These first 3 sets here, all 51 of those videos have already been published on YouTube in their entirety, objective by objective. Please make good use of them. Section 4, measurement. 5 of those have been published on YouTube in their entirety, 5 out of 17. Section 5, statistics. 5 out of these 18 have been published on YouTube in their entirety. Section 6, algebra. 7 out of these 22 videos have been published on YouTube in their entirety. It took a lot of time to set up the online school, so the need arises to reschedule the last 3 parts. So section 7, relations, functions, and graphs. This is the 6th of 26 videos, and hopefully this should be completed by the end of February 2026 or thereabouts. Section 8, geometry and trigonometry, by March 2026. And section 9, vectors and matrices, by April-May 2026. Please note this disclaimer down here. This schedule is just a projection, and it is not to be interpreted by anybody as a contract. Just a reminder again that from section 1, all 33 videos have been published on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. And if you look carefully, you would find some simple things that are done probably in grade 5 and grade 6 in primary school, like add, subtract, multiply, and divide decimals, add, subtract, multiply, divide fractions, and so on. Reminder also that you need to know the times tables from 2 to 12, especially since calculators are not allowed for paper 1. From section 2, consumer arithmetic, all 12 of these videos have been published on YouTube in their entirety. From section 3, sets, all 6 of these videos have been published on YouTube in their entirety. Section 4, measurement. Some of these have been published on YouTube in their entirety, as indicated by these yellow boxes here. The others are only partially published on YouTube. If you would like to get full access to these that are only partially published on YouTube, please see directions in the description below. Section 5, statistics. These videos you see indicated in yellow here have been published on YouTube in their entirety. The others are only partially published on YouTube. Again, please see directions in the description below for full access to these videos that are only partially published on YouTube. Section 6, algebra. These 7 videos indicated by yellow here have all been published on YouTube in their entirety, especially since algebra seems to be a problem area with most learners. So 7 of those videos are published totally on YouTube. The others, the same principle applies. They are partially published. Please see directions in the description below if you need full access to these videos that are only partially published on YouTube. We are now at section 7, relations, functions, and graphs. This section has 26 objectives, 1 objective per video, so we will have 26 videos. Before we go on, recall I said in the introductory video that you will need a good math textbook or maybe a set of 2 to get especially more practice questions. CSEC recommends these shown on the right here. From those, please pay close attention to the last 2 down here, especially since those form a very good 2-volume set of math textbooks that is quite adequate for the current and the future CSEC math exam. This is a picture of volume 1, Mathematics, a Complete Course with CXC questions by Raymond Tulsi. And this is a picture of volume 2. Another disclaimer down here, I get no financial or other benefits from the sale of these books. Also, as of late 2024, a website with AI interactivity has been made available, free of cost, that deals with past CSEC math questions only. You can navigate by topics or years, where all questions for the past several years have been worked out for you. If you still have a question after that, and you need it explained, you can ask the AI assistant either by text or voice, and most likely that will be explained for you. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL of that website. The RSC homepage is shown on the next slide. RSC student. This is the homepage for that website. You will have to register first and subsequently, of course, sign in. Again, that's the URL up there in blue. This URL will be in the description of this video below, so you can easily click on it and be redirected to this website. Just a reminder that this formula sheet that you see on the left here is provided for the CSEC math examination papers. It is also included in the syllabus if you have a copy of the full syllabus. If not, there will be a link in the description below from where this formula sheet can be downloaded. This is the top part of that formula sheet, so you could see it a little closer. Please note that you do not need to memorize these formulae on this formula sheet, as this sheet, as I said before, will be provided during the math examination. And this is the below part of that same formula sheet. While you do not need to memorize these formulae, you do need to know when and how to use them. So we are here, section 7, relations, functions, and graphs. This is a print screen from the syllabus up to objective 5, and all these 5 objectives on this page have been completed. Objective 6 is where we are right now. This is a print screen of 6 to 9. So we are at objective 7.6. This is what we will be doing in this video. And then a brief preview up to objective 13, objective 17, up to objective 20. These are all print screens from your syllabus. Objective 22, and finally up to objective 26, just so you will know where we are and where we need to reach for this section. So we have finished these two up here and they are totally published. The other three up to video 5 are only partially published. We are now here at video 6. When this is finished, it will only be partially published on YouTube. Draw graphs of linear functions. That is what we are doing now. Objective 7.6, draw graphs of linear functions. And we need to talk about the concept of linear function, types of linear function, and you are given 3 of them. This one here, that one there, and that one there. Actually, they're all basically the same thing, this one here. Before we do that, actually, please note that objective 6 says, draw graphs of linear functions. Now look carefully at the following 3 objectives. Objective 7, where you have to determine intercepts of the graph of linear functions. You have to do that graphically or algebraically. And as we deal with this first objective, we will meet that. Then objective 8, determine the gradient of a straight line. So we have to talk about what is a gradient and so on. We have done some of this already, but in dealing with this objective here, this first one, 6 here, we will be dealing with objective 8 as well. And then objective 9 says to determine the equation of a straight line using 4 different conditions. We will cover a few of these in this objective 6 here. Once you understand what we are doing in this video, objectives 7, 8, and 9 become very, very easy. So let's get back to objective 6. Draw graphs of linear functions. Recall for the last 3 objectives, we were talking about functions. Distinguish between relation and function. That was the last objective. So objective 6 is a continuation of 3 to 5 into 7, 8, and 9. Now recall the last 3 objectives deal in detail with functions, as shown above. In this objective, we are dealing specifically with linear functions. So what is a linear function? A linear function is a relationship between 2 variables where a constant change in the input, which is the x value, always produces a constant change in the output, which is a y value. This relationship is represented by a straight line when graphed and can be written in the form f of x is equal to mx plus c. Note that in the function f of x is equal to mx plus c, this f of x here can be replaced with y, so it now looks as y is equal to mx plus c, which is the defining equation from the function. In the format f is equal to mx plus c, m is the slope or gradient. Remember I said we will have to do some things about the following 3 objectives while we are doing this one. So m is the slope or gradient, c is the y-intercept. The slope or gradient m indicates the steepness and direction of the line, while the y-intercept c, that is this c here, is the point where the line crosses the y-axis. So if you look at this equation here, y is equal to 2x plus 4, that is a straight line. That will give you a straight line. So it is a linear function. This next one over here, y is equal to 2x squared plus 4. This will give a parabola. And we are not dealing with a quadratic equation for the next 4 or 5 objectives. So we are dealing with straight line. How do you know if the function is linear? Check to see if this x value here, the highest index is 1. The highest index is 1. You may not see a 1, but remember, if you don't see a 1 is understood to be there. If you see a square here, it is not linear, it is quadratic. So we begin with y is equal to mx plus c, this one here. Once you understand this, the other two are really variation of that one. Example 1. Consider the equation y is equal to 2x plus 4. If you take the domain values, the x values, from -5 down to 5, you substitute that in there, you will get the range values. And this will give us ordered pairs. That will be the points we will plot on our graph. So you draw your two axes. Note the x-axis is -5 on the left here to +5 on the right here, but you go a little beyond that. And the y-axis is -6 down below here, somewhere down here, and it goes up to 40. This axis has actually 50. So you draw your two axes, you scale them out, and then you plot the points. And then you draw a straight line, joining all the points. You notice the r² value here is 1, meaning that all the points fall exactly on the straight line. So that's how you draw a graph of linear functions. Remember, linear means this x here has no square index or cubic index. Its highest index is 1, which you don't see written there, but it is understood to be 1. We actually overkill this one, and I'll explain that. For linear graphs, as long as you know it's a linear graph, you do not need all these ordered pairs that you see on the left here. You just need the two extreme pairs and one somewhat in between. So maybe that one or the one below there, and then this one here. So you have the two extreme and one somewhere in between here. Why? Because you would notice that all the other points, if you didn't have them, they would actually be on the line. So all you will need would be those 3 points indicated in green here, that the two extreme and one somewhere in between. And you draw the line. All the other points will fall on the line, as you can see here. So this is a little overkill. You don't need all these ordered pairs, just 3 for a linear function. Now C is the y-intercept. This here C, y is equal to mx plus c, which is 4. That is where the graph cuts the y-axis. Remember I said we will be looking at the next 3 objectives as well as we go along, even though we will do those as separate videos. Now y is equal to mx plus c. This m here is actually the gradient. So if you find the gradient of this linear function, we will get 2. Let's actually do it. So m is the gradient, and from the function, from this equation, the gradient is 2. So let's find the gradient. Gradient is equal to increase in y over increase in x. We will pick a point up here and pick a point down here, draw that right triangle, and then call this one up here 2's and call this one down here 1's. So you get gradient is equal to y2 minus y1 divided by x2 minus x1. You substitute the numbers, this 8 up here minus this -4 here, over 2, this 2 here, minus this -4 here. You work that out. This line here is 6, and this one over here is 12. So we divide and we get 2. But remember we said, looking at the function, this number in front here is the gradient, provided of course y has a 1 in front here. No other number is there. Now we will vary that example 1 slightly. What we had was this. Notice this plus 4. From that, we know that the y-intercept is plus 4, and we know that the gradient m is plus 2. Now let's make that equation y is equal to 2x plus 7. Is just an overview of how the videos from this section will be published. Right now I am at video 6, for example. That will be published partially. But even those that are published partially, you can still learn something from them because you do have part of the video. And of course, those that are published in their entirety, that is the complete video for that objective.